So in this tutorial we're going to consider how to group raw data. So we're going to take the raw data that we had in the last tutorial, and this time we're going to group it in a slightly more sophisticated way into class intervals. So let's have a look at the raw data that we're working from. This happens to be the weights of 100 domestic cats. So we've got a very small cat here and a very large cat here. So they're ordered into weight, into ascending order. So the data is in ascending order. Okay, so our very tiny cat, originally we were rounding as 4. We were rounding 3.8 up to 4. This time I'm just going to work with the 3.8, the raw data, the original measurements that we had here. So the very first thing we want to do when we're working with a data set like this is consider the graph that we want to end up with. In other words, how we're going to represent that data when we draw it as a graph. So let's draw a set of axes. And now what we want to do is transfer the range of the data here excuse me, onto the horizontal axis. So we've got 10 squares here. How are we going to divide this up? Well, previously we numbered it up 4.5 to 5.5 to 6.5, and it's much better actually if we just use whole numbers. So 10 squares, we want to get a range of data from 0 to, well, roughly 20 to capture the full range of the data. So 10 squares, 20 is our range. So if we number it up in 2s, we'll have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so 20 here, and we're going up in 2s. Okay. Now what we've done here is we've defined what we can also call bins. If we remember the Galton board, or the bean machine, which drops balls into bins, what we're going to do is drop this data just like the balls into these different categories. So if we drop 2 into here, we're going to drop maybe 2 into there, 2 into there, 5 into there, and so on, going right across the graph. But instead of balls, so let's get rid of those balls, we're going to fill up with, as it were, sand or area. So how we're going to transfer the data from here to here is very important to think about. And what we're going to do is start with the 0 category, and to do that, what I want to do is make a frequency table. Okay, so let's draw a t-table now, like that. And our headers will be, well, we've got the intervals here, so it's the range of each of the intervals. And this column will be our frequency. So let's just call it frequency. Okay, now it's just a case of transferring the data into our table and then using the table to complete our graph. So the first interval is from 0 to 2. So from 0 to 2. And a good way of notating that is to say, well, what are we recording? We're recording every time the weight, so let's call it W. And the weight is going to be greater than 0. So we'll use the greater than symbol, looking right to left. So the weight is greater than 0 and less than 2. But it could also be equal to 2. So it's very important to decide, for example, if you've got the 6.0, is it going to be on one side of one of these boundaries or the other? Is it going to be in this bin or this bin? So we have to write not just less than 2, but also equal to 2. So less than or equal to 2. So how many values are between 0 and 2? The answer is 0. So we'll just record that as 0. Okay, what's our next interval then? it's going to be from 2 to 4. How many are there between 2 and 4? Well, I've already marked these in colour so we can see it clearly. Between 2 and 4, there's just one value, the 3.8 here. So we record the number of times the value occurs, and in other words the frequency, and in this case it's just 1. So let's record just 1. Now we've got from 4 to 6 inclusive, and the number is 5. There are 5 values that are between 4 and 6, including this 6. So 5. Now you might want to count using a tally system, and in fact that's quite a good idea because it will immediately show a kind of graph if you do. I'm simply going to count. So we've got 10 here, 5 here, so that's 15, plus another 3, that's 18. Now between 8 then and 10. Here the tally system would really go an awful long way, so I'm simply going to count it. I've got 50 here, plus that 7 and that 3 gives me 60. Finally, well not finally, I've got a few more categories to do, so let's have 10, whoops, 10. In fact, it's a good idea maybe to just get this numbering right. 10, 12, 14. By numbering it up following a pattern. Okay, again these symbols are going to be the same, so it might be an idea just to fill them in very quickly. And our W right the way down. Okay, so how many values are there between 10 and 12? Well, it's these red ones here, so we've got 11. How many are there between 12 and 14? Just these ones here, so 2. How many are there between 14 and 16? Again, 2. And now I've got 1 and 1. Okay. So now we can fill in our chart. We simply take the values from the frequency table, and that will give us the height of our bars. So we need to number up our bars. We know that the maximum frequency is 60. So that needs to be at the top here. And if I just number these down, I'll have 10, 20, 30, 40, 50, up to our maximum number 60. So between 0 and 2 is 0. Okay. Between 2 and 4 is 1. About there. 5 is the next value. Is that right? Actually, let's have a look. I think I've made a mistake. Yes, we've made a mistake here, so let's just erase that. Not 5, but 4. Okay, so we want to do this accurately, make sure we haven't made any mistakes. Okay, so that's 4. Now, between 6 and 8, we've got 18. That'll be about here. Between 8 and 10, our largest category is going to go up to here. Between 10 and 12 is 11, so that's going to be here roughly. Between 12 and 14, 2. Between 14 and 16, 2. And then 1 and 1, so about there. And now, rather than joining it up with a line, a much better idea is to join it up with those bins. And the bins, as I say, this time are going to be filled with sand. They're going to be areas rather than lots of little balls dropping in there. So let's just fill it up with these rectangles. So we're going to start with 0 to 2. Well, 0 to 2, there is no value at all, so we don't fill that in at all. Between 2 and 4, we've got 1. So we need to fill in right up to this dot here. And then all of the other values exactly the same way. Until finally we've completed what we call a histogram. Okay. Oh, finally, before we go on to part 2 and have a look at different ways of doing a histogram like this, let's just label up our axes. So very important to make sure your axes are labelled. So what have we got here? 2, 4, 6, 8. Nobody can tell what we've actually recorded here, so we need to write what it is. Well, in this case, in this particular case, it's the weight. So we've got weight in pounds. And frequency. Okay, and now we're done. Now, it might have occurred to you lastly to ask the question, well, why did we choose 10 bins? Was it simply because we had 10 squares on our horizontal axis? And is that a good reason to choose this number of bins? So lastly, I want to ask, how many bins should you choose? Well, if we look at the Galton board, the answer is fairly straightforward. There really ought to be 6 bins, because each one of these balls is going to have to make 5 choices as it goes through these 5 rows. And because, if you know Pascal's triangle, because there are a certain number of ways of getting into all of these bins, plus a way of going left 0, if the combinations approach is familiar to you, then you'll realize that you need the number of rows plus 1, giving you 6 bins that you can see here. So that's fairly straightforward for the Galton board, but if you think about it, when we're looking at any normal statistical situation, that's not so clear, because we simply don't know the mechanism that's giving us this distribution. All right, what I've done here now is draw a set of axes with just 2 bins, and we're going to use the same data that we had before. So what would happen now if we dropped this data into just 2 bins, into 2 class intervals? Well, how would we label these? Again, the maximum of 20. So this central area here, this boundary, is 10. So we're either going to say that a value is in this bin here, so up to 10, up to and including 10, or we're going to say it's in this bin here, up to and including 20. If we number up our vertical axis, so up to, what have we got, up to 80 here, and then let's just count how many are up to 10. Well, all of these up to here are up to and including 10, so that's 8 rows plus 3, giving us 83. So on my axis here, on my chart here, I'm going to put a dot at 83, and 100 minus 83, there must be 17 left. So 17 must be about here. So now let's get rid of the raw data, and if we draw fill in our bins up to that point, there we go, up to this point. The question we can now ask ourselves is that a good diagram? Would that be sufficient to show the data as clearly as possible? Well, not really. We've got what seems to be what we call skewness. It seems as if the data is mainly going into bin 1, which doesn't suggest the symmetrical curve of the normal distribution, even though we know that this data is pretty much normally distributed. Let's compare it then to the chart that we just drew. So again, if we number up to, what have we got here? Up to 60. On the horizontal axis, again up to 20. But this time we're going up in twos. So the question we've got is, does that produce a better histogram? Histogram, the name of the chart that we're drawing here. Oh, okay. 16 and 18, 20. There we go. Well, as we've seen, and if we just quickly draw in the data that we had before, this gives us a much better sense of the distribution of the data, so that we can look at the shape made by these bars and see very clearly that it's pretty close to the normal distribution. How about though if we increase the number of bins, so that instead of going up in twos, we go up in ones? So in other words, that we have 20 bins. So let's have a go at that. Okay, let's number this up. So we don't need as much numbering on the vertical axis, and let's just number this 20, and I guess it would make sense to identify the midpoint 10 again. Okay, now if we look at our raw data again, we can see a very different spread now. I divide it up into these categories, and just for the sake of speed, so we don't take too long doing this, I'll just fill in those now very quickly. Okay, well there it is. You can see we've got 1 or 2 here, we've got 1 here I think, and it goes up to well, I think it's about 31, 32. Have we got a better spread here than we've got here? Well, I think definitely we have. Whether it's worth the effort is difficult to say though. Here we've got a fairly clear curve suggesting the normal distribution, and that's really just been repeated here in a similar way, just with a few more class intervals. So it's probably sufficient just to use the 10 categories, the 10 class intervals that we've got here. But let's do one final check, which is to have a look at the mode. Now the modal value we know for our weights of cats was 9. So if I take the mode as being 9, I can draw a line on each of these diagrams, and we should be able to see, so if I draw a 9 here, okay, we should be able to see the difference between the diagrams. So here we've actually got the mode going into this half of the bins, which doesn't feel very good at all. Here we've got it going up one category, so it's bisecting the 8 to 10 category. And I suppose you could say then that this is slightly better, because if we have at least two of the bins either side of the mode, we can see more clearly that we've got the curve at the top of the normal distribution. However, it's really an art rather than a science, and it's up to you, I guess, how many, let's have a look at the tails here, how many of these bins you're going to decide upon. One final thing that we might ask is there a limit? are there a number of bins that really won't be very helpful? Is there an upper limit? Well, I'm not going to draw it out, but let's consider if we had 100 bins. If we had 100 bins, then some of the data would be repeated. So you might get 2 or 3, probably at most, repeats in the data. And so the axis, the vertical axis, would go up to a maximum, I guess, of 3. The horizontal axis is going to be a really long stretch. So if you're going to fit it in for a start, you're going to have to make your rectangles very thin. But the main problem with going up to 100 bins would be that it would be very difficult to see any kind of pattern. So the upper limit of 100 is going to be unhelpful because it's squashing the histogram down far too much to be able to see this pattern. So you could think of it as what we want is a decent vertical axis, so going up to 30 or 35 here gives us a decent height, and you also don't want too many bins on the horizontal so that it doesn't get too fat. Apart from that, there really is no right or wrong answer to the question how many bins. It's something that you need to judge every time you look at a fresh piece of at a fresh data set. Okay.